So we're going to talk about geometric sums, right? Also called geometric series again today. And there are some crazy things that can happen. So a geometric sum might look like this: 1 plus 2 plus 4 plus 8 plus all the way up to, let's say, 256. And you can add these up. And you could add them up if you wrote all the terms out, obviously. Just plug it into your calculator, or you could use this formula. S sub n equals a sub 1 minus r to the n over 1 minus r. And that's what we talked about yesterday. And what you can see is that the number that we're multiplying by is 2. So I know r is 2. We can write that down. And we know our first term, a sub 1 is 1. And we don't know how many terms we have. So either you want to write them out, but I'm going to use a little shortcut. A sub n equals a sub 1 times r to the n minus 1. And I'm going to plug in what we know. For some value of n, we have 256. A sub 1 is 1. R is 2 to the n minus 1. So 256 equals 2 to the n minus 1. And I am just going to play around with that, do a little guess and check. Let's see, 2 to the 8th. I could write the left-hand side as 2 to the 8th equals 2 to the n minus 1. If the bases are the same, then we know the exponents are the same. So n must be 9. It was kind of a lot of work. But now we can find the sum of those 9 terms is going to be 1 times 1 minus 2 to the 9th over 1 minus 2. 1 minus 2 I can just write as negative 1. So this is going to be 1 divided by negative 1. I'll pull that out. 1 minus 2 to the 9th, which is negative 1 times 1 minus, and let's see, 2 to the 9th is 512 on my calculator, which is going to give me negative 1 times negative 511, so that's going to give me 511 as my sum. Okay, so that's stuff that you know. Now, here's something here's a question. Suppose this didn't stop after 9 terms. Suppose I said, add up all of the terms in the whole series. Let's not stop. Let's just keep on going until the day that the world passes away, right? What are those going to add up to? And you can't do it because you know that we're adding bigger and bigger and bigger numbers. So this is just going to be infinity, right? You can't do it. Okay, here's another situation. Here's another geometric series. 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus, right, at a certain point we get to 1 over 256. At a certain point we get to 1 over 512, right? Blah, 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 blah. And you notice that these numbers are getting smaller and smaller and smaller. And here's one way to picture it. Suppose I had a square, and the sides of the square were 1 by 1. So the area of that is 1. So when I take 1, it's the area of that square. Now I'm going to have a similar square, exactly the same size. I know the total area is 1. So if I want to add 1/2, well, half of the square is going to give me an area of 1/2. And then 1/4 is 1/4 of the square. 1/8 is half of that. 1/16, 1 over 32, right? I could keep on going, and I'm always going to be dividing this into a smaller and smaller piece. So if I was going to add infinitely many of these, just keep going on and on forever, what I know is that it's never going to bust out of this second square. So by the time I add all of them, it's going to get very close to the number 2. And let's look at how we could come up with that. I'm going to go back to this formula. 1 minus r to the n over 1 minus r. And what we find is that if r is less than 1, as it is here, if I take 1/2 and I raise it to some fraction, right, 1/2 to the n is the same as 1 to the n over 2 to the n. 1 to any power is just 1. And as n gets bigger and bigger, this is the word limit again, right? The limit, the trend as n goes to infinity, is that this is going to get close to 0. So when r is a fraction, this is going to go away. So we're left with, if we have what we call converging sum, our sum formula is going to be a sub 1 over 1 minus r. A sub 1 is 1. R is 1/2, so this is 1 minus 1/2. So this ends up being 1 divided by 0.5. And on your calculator, you're going to get